Hello, everyone. This is Miss James. I'm sorry I can't be there in person, but this is probably the very next best thing I can do. Today, we just need to figure out the results of our free fall lab. So I'm going to walk you through that in a 5-10 minute video, and then I'm going to leave it to you to write a conclusion. So for most of you, you see the data up here. Um, your data doesn't exactly look like this because you have to, what I've done here is I've isolated the good data. So you probably haven't done that. And so, particularly for things like Logger Pro, when you drop the book, there's noise in the start, there's noise in the end. And in the last few classes, I've tried to show you what your good data is. And it's not long. Look at, even on my graph, and I have more points than you probably do. We're talking about less than a second worth of good data. So be mindful of that and try to really pinpoint what your good data is. So, as you remember, in a conclusion, we're answering the following questions. What is the scientific question? And remember, in this lab, we're trying to figure out, how do objects in free fall move? That was our scientific question. And there are really two answers that could possibly happen. One is that the motion has a constant velocity, and the other one is that it has a changing velocity. So think about what the result was. The result was that we didn't have a constant velocity, right? We had a velocity that started low and ended high. So we didn't have a constant velocity. We definitely had a changing velocity, and therefore we have an accelerating object. Okay. You can show that result using the table. In your Logger Pro tables, you will have a column of velocity. What was the start velocity of your good velocity? What was the end velocity of your good velocity? And then that shows that you had a changing velocity. Now you can describe the shape of your graph supports the results. Um, what is the shape of the distance graph? Is it a line or is it a curve? This is actually a curve. You can see that if I tried to fit a line to it, we have points over, we have points above the line, then points go below the line, then points go above the line again. That's not a line. That is a curve. And we'll talk a little bit more when we get back from break about what kind of curve it is. But at least for now, it's a curve. And the shape of the velocity graph is a straight line. And both of those things indicate an acceleration. Now we can go a little bit deeper. We see that the acceleration is the slope of the velocity time graph. The acceleration here is 9.7 meters per second per second. That tells you that that's what your acceleration is. And it's interesting because the accepted value, the value that other scientists get with a lot of fancier machinery than we have, is 9.8 meters per second per second. So this is the value we should have gotten. And of course, since it's my data, it's perfect. I got 9.7. So maybe not perfect, but close. We can compare using percent difference. So in this case, I would take 9.8, my accepted value, minus 9.7, my observed value, and divided by 9.8, my accepted value. Break out my calculator here. I've got 0.1, which is 9.8 minus 9.7, divided by 9.8 And then, of course, I've got to times it by 100. And I've got a 1% difference. So talk about that in your lab. Now, why did the results happen? What's happening as the ball falls? Oh, yeah, we have gravity. So gravity seems to pull objects down. And again, we do have an accepted value of 9.8. It will be interesting to talk to your classmates. Did that happen in the other two labs? Did they also get values that were close to 9.8? You have shared the data, so you do know what values they got. And you should see that they are all pretty close to 9.8, which tells you a couple of interesting things. It doesn't depend on the mass of the object, which is a little surprising. Heavier things don't seem to accelerate faster than lighter things, which is interesting. So, and it also didn't depend on the shape of the object. We had the slim picket fence, we had a heavy textbook, we had a basketball. Spend some time talking about what the sources of error were for your lab. They do vary based on the different labs. And then, what is the next step? What do you want to do next? So, what I'm expecting you to do in class today, after this admittedly brief discussion, is write up what's happening in your lab. And it probably will be a page. Make sure you put in your data, copy your data into a Word document, make the whole thing a PDF, and then upload it onto the Moodle on the current day. All right, guys. Thanks so much for your patience. I hope you have a fabulous break. Bye now.